Okay, so in this video we're going to be doing just integration questions, and so in my analysis of the Pure 1 exam we found that there was they ask on integration every year, and I made a worksheet for you where I categorized it into three ways: finding the equation of the curve, finding the area, and finding the volume. And I thought in this video we could just go through some of those questions from the worksheet to help you get a better understanding of integration and how they ask it. So let's just do that. And we're going to do two from each section. So two questions from the find the equation of the curve part of the integration, two from find the area, and two from find the volume. So let's begin with so this is extracted from the worksheet. So we have a curve here, which I'll just write out. So this is a dy by dx equals 8 over 5 minus 2x squared. And this, given that the curve passes through 2, 7, find the equation of the curve. So we have the derivative of the curve, which is this expression, so we know we're going to have to integrate to get the y. So straight away what I do is I put this in, I'd bring this whole part up because I know I'm going to have to integrate. It'd be useful in this exponential form. So we have that dy by dx equals 8 times 5 minus 2x to the negative 2. So now, and I'm going to be super explicit about all of this, as I like to be, to show you exactly what's going on. I'm going to times both sides by dx here. And then I'm going to integrate in both sides. And the integral of this is y. And it's y equals 8, 5 minus 2x. We go up by a power, and then divide by the power, and then times by the derivative of this, what's in this fraction, which is minus 2x, and then we have this plus c on the end. So we can simplify that more, and we get, oh, not 2x. The derivative is minus 2. The derivative of this with respect to x is minus 2, so we divide by that. So we get 8 divided by this, which is 2, so that's 4 times 5 minus 2x to the negative 1 plus c. We can rewrite that again to make it look even better. 5 minus 2x plus c. Now we have this, but we don't have this c, but we know that it passes through this curve, y curve here passes through the point 2, 7. So we can substitute in the point 2, 7 to find our c. So when y is 2, x is 7. When y is 7, x is 2. So we get 7 equals 4 over 5 minus 2 times 2 plus c. So that's 7 equals 4 over, this is going to be 1, so we get 4 plus c. Therefore our c equals, take that over, we get 3. So our final equation becomes y equals, for the curve, 4 over 5 minus 2x plus 3. And that's your answer. Okay, let's move on to another one of these find the equation of the curve. And in this one, you're given actually a second derivative here. And it says that, so you're given the second derivative of f of x is 12 over x cubed. And it says that the curve y equals f of x has a stationary point. So there's a stationary point on this curve at 2, 10. And it says find f of x. Well, this we can say, because I like to be very clear when I do these to show you exactly what I'm doing, I can say that this f double prime of x, well, remember this is just the notation for the second derivative of f of x, which if you think about it is just this times, let's be everything, The reason I'm doing this is just to show you really what's going on. I could just integrate it straight away, but I just want to show you what I'm doing. And this is d times, so this is the same as this, right? If you times this in, you get this. And this is d by dx of f prime of x. So this is the derivative of the derivative, which is the second derivative. So you can say that f prime of x equals df of x, so the derivative of the derivative. And the reason I do that is because, well, that means that this equals 12 over x cubed. So we get we can bring this up, so we can integrate it. We get that d f prime of x equals, we take the dx over 12x negative 3 dx, and we integrate both sides. And this, well, just like if it was the integral of dy would become y, well, the integral of df prime of x becomes f prime of x equals this integrated will be 12, and go up by a power, which is negative 2, divided by the power. And then again we have this plus c. So we get f prime of x equals minus 6x to the negative 2 plus c, and that's just minus 6 over x squared. Okay, and we know that this curve has a stationary point at 210. So that means that if the curve has a stationary point at 210, that means that the derivative of the curve at x equals 2 is equal to 0, right? If there's a stationary point at 210, means there's a stationary point at x equals 0, which means that the gradient, there's a stationary, if there is a stationary point at 210, that means that the derivative of the curve at x equals 2 is equal to 0, and that's exactly what we did there. So that means that we can plug this in. So f prime 2 of 0 equals minus 6 over 2 squared plus c, which equals 0. So from this we can then find RC. Right, so we get, therefore we get, this will become minus 3 over 2 plus c equals 0. So therefore our c equals 3 over 2. So now we have an equation for the derivative of f of x, which is here. So minus 6 over x squared plus 3 over 2. Okay. And now we want to find f of x. So we have to again integrate again. So remember, this is the same as saying d of f of x dx. And that equals, we can bring this up, we say minus 6x to the negative 2 plus 3 over 2. Right? And we can take that dx over. And integrate both sides. And we get here that this is f of x, the integral of d of f of x is that. And the integral of this, well, we can say that we can integrate each part individually. Because you know this is the same, if you just were wondering, this is the same as saying minus 6x to the negative 2 dx plus 3 over 2 dx. It's the same thing. There, I think the word is distributive, so that means that they can, you can add them. It's the same as adding them together and integrating and adding them separately and integrating separately. So this is going to be the same as saying minus 6x to the negative 1. You got a by power, divide by the power. And then plus 3 over 2x plus, again we have this plus, a plus c on the end. So therefore f of x equals, well, this is 6 over x plus 3 over 2x plus c. But we know that the curve passes through the point 210. So there's a stationary point at 210, which means the curve passes through the point 210. So that means that when f of x, equals 10, x equals 2, or f of 2 equals 10. So 10 equals 6 over 2 plus 3 over 2 times 2 plus c, which gives us a 10 equals 6 over 2 is 3, so this is 6 plus c, so therefore our c equals 4. So finally we can say that our f of x then equals 6 over x plus 3 over 2x plus 4. And that's your answer. So those are two examples of integrating to finding the curve. Now let's do some find the area examples, integration examples. And this one says wants you to show or wants you to find this. So we have a definite integral of the square root of x plus 2 over the square root of x dx. And like in all of these ones, what we immediately do is we always change this into exponential form so we can actually integrate it. So this is the same as saying x to the half plus, well, this is 2 over x to the half, and then if we bring it up, it will be 2x to the negative half dx. And then this means simply becomes, we can say that this equals, we go up by a power, which is 3 over 2 for this first part, divided by 3 over 2, plus this go up by a power is negative half, plus 1 is a half over 1 half. And then this is calculated for between the 4 and 1 limits. So let's simplify this one more time. So this will become 2 over 3 x to the 3 over 2 plus, bring this up as 4 x to the half between 4 and 1. And that equals 2. We do it for 4 first, we substitute in 4 of 4 to the 3 over 2 plus 4 times 4 to the half minus 2 over 3 to the 1, 2 plus 4. Remember these are just going to be 1, but I'll write it out anyway. Is anything to the power, 1 to the power of anything is 1. And if you plug that into your calculator, you will get, did this before, 40 over 3 minus 14 over 3, which gives you 26 over 3. So therefore this, of square root x plus, what was it, 2 over square root x equals 26 over 3. Okay, and let's do another one where we calculate the area. So here we have a diagram showing a line and a curve, and we want to find the shaded area. Well, in order to do that, the first thing that we have to do is we have to find the limits of this, because we know that the shaded area here, so we call it AS, the area of the shaded area, is going to be the area under this curve between this x value and this x value, minus the area under this line between this x value and this x value. So we can say this is the area shading region, is the area under this curve, we could call it AC, minus the area under this line. But first we need to find the limits of these integrations, and the way that we do that is, well, we can see where do they intersect each other, because we know at these points, their y values are going to be the same. So we have that y equals 2x plus 1 for the line, and for the curve we have this. So the intersection is when we equate them, so we get 2x plus 1 equals minus x squared plus 12x minus 20. So take the x squared over, take the 12 over, 2 minus 12x is minus 10x, and take the negative 20 over, gives us plus 21. And then we can factorize this like so. What pluses into this and times into this. So our solutions are x equals 3 and x equals 7. So that means this is 3, x equals 3, and x equals 7. Now we can say that the area of the shaded region is equal to the area of under the curve between these limits minus the area under the line between these limits. So we find these individually. So the area under the curve is going to equal to the integral between 7 and 3 of this curve. So for the curve, which is minus x squared plus 12x plus 12x minus 20 dx, and we can figure this out. So this is the same as saying minus x, go up by the power, divide by the power, plus 12x squared divided by 2, well that's just going to be 6x squared minus 20x, up by a power, divided by the power, between 7 and 3, and then we can put this in, so we get minus 7 cubed over 3 plus 6 to the 7 squared minus 27, all of that minus, and then we substitute in the 3. And I did this before to save time. That is 119 over 3 minus 15, which gives you 54 and 2/3. So that's the area under the curve between x equals 3 and x equals 7 is 54 and 2/3. And now we need to find the area of the line between x equals 3 and x equals 7, which will be 7, 3. And the line is y equals 2x plus 1. So it's 2x plus 1. And if you don't understand why this is the area under the line between those limits, go and look at the exam hack video on integration, which I would recommend watching before you actually do the questions, because it shows you the categories and the intuition behind them. So this is going to become 2x squared over 2 plus x, which is x squared, plus x between 7 and 3, and that becomes 7 squared plus 7 minus 3 squared plus 3, which equals 49 plus 7 is 56, minus 9 plus 3 is 12. So that equals to 44. So AL is 44. So therefore, finally, the area of the shaded region is equal to 54 and 2/3, which is this, the area under the curve between 7 and 3, or 3 and 7, minus 44, the area under the line between 3 and 7, which equals 10 and 2/3. So the area of the shaded region equals 10 and 2/3, and that one was 8 marks, that's a lot. Okay, now we can move to define the volume. We are given a curve and a line, and it wants us to find the volume obtained when it's rotated 360 degrees about this x-axis. And that means that if we want the volume of the shaded region, well, this is going to be the volume of this rotated line, which will VL, minus the volume of this rotated curve between the limits of P and Q. And so first let's find these limits of P and Q. Well, that's just going to be where the line and the curve intersect, which is when y equals 4 intersects with y equals x over 2 plus 6 over x. So we equate them, we get 4 equals x over 2 plus 6 over x. So let's times through by x. We get 4x equals x squared over 2 plus 6. Times through by 2, we get 8x equals x squared plus 12. So therefore we get x squared plus minus 8x plus 12 equals 0. And then we can factorize this to find our solutions for x, and therefore our p and q x values will be what, minus 2 and x minus 6 equals 0. So we have solutions of x equals 2 and x equals 6. So this will be the p and the q. Okay, so now we need to find the volume of this line when it's rotated around the x-axis between 2 and 6, and the curve when it's rotated about the x-axis between 2 and 6. And the way that we do that is as follows. And the volume of the line, this rotated line, will simply be the integral between 6 and 2 of pi y squared dx, where our y squared, or where our y in this case is 4. And if you don't understand that, watch the exam hack on integration. I explain why this is. And this is equal to 6. We can take the pi out of 2 of y squared is 4 squared, because y is 4 for the line. Well, that's 16. So we get 16 pi 6 and 2 dx. Well, this is 16 pi of x between 6 and 2, which is 16 pi of 6 minus 2, and that's just 4. So that means this is 64 pi. So therefore the volume of the rotated line between 2 and 6 is 64 pi. And now we need to find the rotated curve. So the volume of the curve again is pi between 6 and 2 y squared dx, where the y squared is now this, so x over 2 plus 6 over x. So this is, take the pi out, 6 2 of y squared, which is, what was it, x over 2 plus 6 over x squared dx. So let's work this out here. So let's just do this over here really quick. So x over 2 plus 6 over x times x over 2 plus 6 over x. Expand this out so then we can integrate it easily. That gives us x squared over 2 over 4 plus 6, so it'll be plus 2 times let's just write it all out. 6 over x plus 36 over x squared. It gives us 2 lots of these. So therefore we get x squared over 4 is 2 lots of these, so plus 2 lots of 6 over x over 2. So that'll cancel with that, that'll cancel with that. So this is just 6 plus 36 over x squared. So this is actually pi between 6 and 2 of, it becomes x squared over 4 plus 6 plus 36 over x squared dx. We can write this as 36x to the negative 2. So now we can work this out. Therefore this equals, therefore our volume under our curve, our rotated curve, is pi times x3 over, times down by the power, 4 times 3 plus 6x plus 36x to the negative 1 divided by negative 1 between 6 and 2. And we can simplify that to get x3 over 12 plus 6x minus 36 over x between 6 and 2. And therefore the volume under the curve is this, pi times, well, 6 cubed over 12 plus 6 times 6 minus 36 over 6. That minus 2 cubed over 12 plus 6, 2 minus 36 over 2. And I did this before to save time. So it's 48 minus, this is pi, times 48 minus 16 over 3, which gives you 160 pi over 3. So the volume under the curve is 160 pi over 3. Therefore, finally, we can find the volume of the shaded region, which is the volume under the line, which was 64 pi, minus the volume under the curve, or the rotated curve about the x-axis, which is this. And that equals, didn't calculate that, 64 minus 160 over 3 is 32 over 3 pi. And then we'll do one more. This time, for this one, is rotated around the y-axis. So we'll do one more volume one, and then we've done 2 for each category. So lots of examples, 6 different examples here for integration. So this we have to show for this diagram that when it's rotated about the y-axis, that you have to show that the volume is this. So rotated around the y-axis, you're going to get these like cylinder shapes. And when we change a little dy, the volume of these little cylinder shapes here, these dv's is going to equal to, well, the length here is x. This is where this comes from. I can just show you this really quickly. The length here is x, so the area of this top disk when it's rotated for this small change in dy is pi x squared for the area, pi x squared, times the width of this disk, which is dy. So to find the volume of the shaded region, we have to sum up all of these dv's, along this curve here for between our y equals h and y equals 0. So that's just integral between h and 0 of pi x squared. You can see it's x now because we're actually rotating around the y-axis. Y x squared dy. And our x squared here from this is just simply x squared. If we just take the 1 over, equals y plus 1. So then we can find this. So this is the integral of h0 of pi times y plus 1, because x squared is equal to this, dy. So that equals pi of the integral between h and 0 of y plus 1 dy. So let's integrate this to give us pi of y squared over 2 plus y between h and 0, which gives us pi of h squared over 2 plus h minus 0. So therefore the volume is equal to pi times half h squared plus h, which is what we had above. Right there. Cool, so that's 6 integration examples. Like, subscribe, and I'll see you later, mate.